Most students see this question and immediately think, great, JEE has started throwing random angles again. But here's the twist. These two expressions are not random. JEE is secretly handing you alpha plus beta and alpha minus beta for a reason. And once you see the pattern, this terrifying looking question suddenly turns into pure class 11 trigonometry. The problem asks for tan 2 alpha, but it gives us information about alpha plus beta and alpha minus beta. So how do we connect them? Look at the angles closely. If you add alpha plus beta and alpha minus beta, the beta terms completely cancel out and leaving you exactly with 2 alpha. That means tan 2 alpha is just tan of alpha plus beta plus alpha minus beta. So we don't need a single angle expansion. We just need our classic compound angle formula, tan of x plus y equal to tan x plus tan y by 1 minus tan x tan y. And that is the hidden symmetry of the question. So our mission becomes very simple over here. Let's find tan alpha plus beta first and then tan alpha minus beta and finally combine them using this tangent addition formula. So now we are given this. Here alpha lies between 0 and 60 degree and beta lies between 0 and pi by 4 means 45 degree. So definitely alpha minus beta will be less than 60 degree. So which means alpha minus beta lies in the first quadrant, which means tan alpha minus beta is positive. Also, if I find alpha plus beta and add the two angles, we are getting 7 pi by 12, which is less than pi. So which means this angle has stepped into the second quadrant. And that is why, please notice that cos alpha plus beta was already negative because alpha plus beta was in the second quadrant. And that is why tan alpha plus beta will also be negative. Next, for finding tan alpha minus beta, we will look at sine alpha minus beta, and we know sine alpha minus beta is perpendicular by hypotenuse, which makes this as perpendicular and this as hypotenuse. And we know tan alpha minus beta is perpendicular by base. So if this is hypotenuse, I can easily find out base using Pythagoras theorem. So we have tan alpha minus beta as 3 perpendicular by base, which is root over 8 square minus 3 square, and that gives me 3 by root 55. Similarly, tan alpha plus beta, which is equal to perpendicular by base, but we have been given cos alpha plus beta, which means this is our base and this is our hypotenuse. So in order to find perpendicular, we need to apply Pythagoras theorem once again. So perpendicular by base, which is 1, we get tan of alpha plus beta as minus 3 root 11 by 1 we don't write. Remember our question? It was given that tan 2 alpha is equal to this expression. So we have tan 2 alpha is equal to this. We'll remove RHS first. Let us put it aside. And tan 2 alpha is equal to this. We have already seen that. If I expand it using tangent sum formula, we get this. Now we already have tan alpha plus beta. So let's put the values in. And we get this. Now we are multiplying the numerator and denominator by root over 55. So we get this. And we can see we have to take 3 common from the numerator and root 11 common from the denominator. So if I do so, we are getting this. And if I flip this, we are getting this. So if you compare both sides, we get r equals to 11 and s equal to 9. So r plus s is equal to 11 plus 9, which is 20. And that is how you disarm a terrifying JEE question using pure logic instead of painful algebra. Remember, the exam doesn't test your math, it tests your strategy. So make sure you smash that subscribe button for Think Sharp Valley so you don't miss question 9. Until then, stay curious, keep practicing and always think sharp. See you in the next one.